Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you evaluation of expressions in query processing and optimization. So let's begin. It is easiest to understand intuitively how to evaluate an expression by looking at a pictorial representation of the expression in an operator tree. So let's see with an example. If you have a query that is like this, where you are trying to find out, first of all the departments which are present in the building Watson, and taking a natural join of that with instructor, and then taking out the names from there. So if this is the type of query you want, you can convert it into an operator tree in this manner. So you can see in the bottommost part, we have department from which I have applied the sigma operation and taken out all departments that belong to the building Watson. And then the join is taken between the result of all departments belonging to Watson building and all instructors. And so once the join is taken, natural join is taken, then the by name operator is used, which will help us to get only the name column. I'm not going to show you now what is there in all these tables because you don't need to understand all that in order to understand what this query actually says and what it means. So we're just going to go ahead and understand how these expressions are evaluated. So the first way to evaluate such expressions is to apply the materialization approach. This approach works in the following manner. We start from the lowest level of operations in the expression, that means at the bottom. So at the bottom, you can see the expression that is there is department, right? So this is our example where in the bottom we have only one expression. This is not always true. It depends on the type of query you have and the type of tree that is generated based on that query. So in this case, we have only one relation, but there could be more. For now, because there's only one, which is the selection operation on department, we are going to go ahead with it. The inputs to the lowest level operations are relations in the database. So definitely when we begin from the bottommost level, we would be working with tables that are actually present in the database. That is not true once we move upwards. Then we might be working with the results of operations performed on those tables. But for now, we are working with operations, we are working with actual tables that are present in the database. As you can see, department is an actual table that's present in your database. And once we apply some condition to this table, then we can use some temporary relations. So we can create temporary relations, and then these temporary relations can execute operations on the next level of the tree where inputs are now either temporary relations or relations stored in the database. So let me explain this a little bit more. In our example, you have here inputs to the join operation, where one input is an actual relation in the table, in the database, which is instructor. But the second input that is going to the join operation is not a table. It is the result of some operation that was performed on an original table. As you can see here, department is an original table on which sigma building equal to Watson operation was performed. And after performing that operation, you are creating a temporary relation which contains only those rows of department where building is Watson. So it's a temporary relation which is then passed to the join operation. So this is the temporary relation, and the instructor relation that you have is the actual relation which is present in the database. Now the join can be evaluated by creating yet another temporary relation, because now you're trying to take a natural join between a temporary relation and an actual relation, and whatever is the result of that natural join will also be stored in the memory as a temporary relation. It is temporary because once the query is finished, once the whole process of evaluation of query is over, those relations will be just removed from the memory, so they are temporary. Whereas relations like department and instructor will still persist in my database even after my query has finished executing. But relations that are created because of sigma and join and pi operations, those relations will only remain as long as the query is being executed. So now once the join is evaluated, there's another temporary relation created, which is also further evaluated, which is where we go on repeating this process, and eventually we will reach the root of the tree, which is the topmost relation, which is the topmost operation and the final operation. And this will give us the final result of the expression of the query that we wrote earlier. In our example, we can get the final relation by executing the projection operation at the root of the tree, using as input the temporary relation created by the join. So the natural join is giving a temporary relation, which is then provided as an input to the root of the tree, which is by name. And then once again, another temporary relation is created, which is then produced as an output. So when you write a simple SQL query, all these things go on behind the scenes. So you won't realize it, but this is what happens behind the scenes when you are trying to run a really small SQL query. It gets converted into an evaluation plan, and then that plan is executed. And to execute that plan, we have several options, and one such method was the materialization method. So the results of each intermediate operation are created, which means materialized, and then they are used for evaluation of the next level operation. So this is the process of materialization. The next approach to evaluate this type of an expression is the pipelining approach. In this, we can improve the query evaluation efficiency by reducing the number of temporary files that are produced. So in the materialization approach, at every step, there is a temporary relation created. If you want to reduce the number of temporary relations created, then we can apply the pipelining approach, which we are going to see now. Here you can achieve this reduction by combining several relational operations into a pipeline of operations, in which the results of one operation are passed along to the next operation in the pipeline. So instead of moving step by step and creating one relation and then applying another operation and creating another relation, here there's a pipeline created. So each row of a table passes through this pipeline. So for example, if you have from the department, if you have one row, and let's say that that row does not have the building Watson, then first you are just going to evaluate that one row. You are not going to evaluate the entire department table. So that one row will be passing through the sigma operation, which is right on top. And with that sigma operation, we will just check if that row contains building Watson or not. And if it doesn't, then you don't have to proceed further in the pipeline. You can just drop that row right there. Then you proceed to the next row of department and find out if that row is having the building Watson or not. And if it is present, Then you just push that row upwards towards the pipeline, and it proceeds and passes through all the operations one by one. And so we are performing a natural join in this case, which means that row will just get compared with all rows of instructor to find out if that row actually matches with something from the instructor table, because it's a natural join. So some common column has to match. Now, this also is done in the form of a pipeline. So every row of instructor will also pass through a pipeline of natural join and pi operations. So in order to avoid the creation of so many temporary relations, we can apply pipeline operation. Now, pipelines can be done in when we perform pipelines, we can get the following benefits. The first benefit is that you can eliminate the cost of reading and writing temporary relation. So the cost of query evaluation is also reduced. This is because you no longer need to create temporary relations. You just need to create a pipeline of operations and apply them on each row as it comes. It can also start generating query results quickly if the root operator of a query evaluation plan is combined in a pipeline with its inputs. So what happens here is we do not have to wait for each operation to finish. Because the operation is being performed on each and every row of the table, we just need to wait till that operation is performed on one row. And if that row qualifies through all the operations, then it can be just shown to the user. So instead of, the user doesn't have to wait for a long time to get the result, the user can start getting result at that moment, because one single row is being evaluated at a time. So if that row fits the description, then all that is needed is for that row to just be displayed as an output. So this is quite useful if results are displayed to a user as they are generated, since otherwise there may be a long delay before the user sees any query results. Now, pipelining can be done in two different ways. The first way is a demand-driven pipeline, and the second way is a producer-driven pipeline. So let's first take a look at demand-driven pipeline. Here the system makes repeated requests for tuples from the operation at the top of the pipeline. And each time that an operation receives a request for tuples, it computes the next tuple or tuples to be returned and then returns that tuple. So this is almost like a programming language where one function is applied on a tuple and the result is returned to whichever place from where that function call was made. If the inputs of the operation are not pipelined, the next tuple to be returned can be computed from the input relations, while the system keeps track of what has been returned so far. So it's possible sometimes that the inputs of that operation are not supposed to be displayed anywhere. Then you can just start computing the rest of the inputs and wait for the system to finish that and then return that input. If it has some pipelined inputs, the operation also makes requests for tuples from its pipelined inputs. So sometimes when you're performing an operation like a natural join, it is not wise to perform natural join with just one single row and an entire table. So for such operations, you might want to wait for the pipeline to gather more data, more rows, and then you want to perform the pipeline. So in demand-driven pipelining, this thing is demanded by the operation or by the system. It is not automatic. When the system demands for more inputs, then it gets those inputs. Using the tuples received from its pipelined inputs, the operation can compute tuples for its output and then passes them up to its parent. So once the pipelined inputs are received by the operation, it computes the output and then passes the output to the parent node, which is the root node. So that is how demand-driven pipelining works in database management systems. And now we are going to see producer-driven pipelining. In producer-driven pipelining, operations do not wait for requests to produce tuples, but instead they generate the tuples eagerly. So like I said, demand-driven is where only when there's a demand, the tuples are generated. But in producer-driven, the operations keep on generating automatically new tuples every time, very eagerly. And each operation in a producer-driven pipeline is modeled as a separate process or thread within the system that takes a stream of tuples from its pipelined inputs and generates a stream of tuples for its output. So even if there's a simple natural join operation, here the system is not going to wait to collect a lot of tuples. It will just start combining that one row with the other table that is available. So even if it's a natural join, you're not going to wait to obtain lots of rows. Even if you have just one row or two rows, you are still going to perform the natural join because this is an automatic process. Whereas demand driven is where the system can request the operation that is going to be performed can request for the tuples when required. So that's how pipelining works in database management systems with these two approaches. And also the other approach we saw is the materialization approach, where there's no pipelining and there are many temporary relations created. And this is how expressions are evaluated in database management systems in query optimization and processing. And that's it for this video. I'll see you in the next one. Thank you for watching.